Hello beautiful kids, how are you all doing? Welcome to a new science lecture video and we're still talking about light. Light is a type of energy and it is produced from different sources of light. The sun and the stars are natural sources of light, while light bulbs and fairy lights are artificial sources of light. Light is made of electromagnetic waves that travel through space in straight lines called rays. When it rains, the visible white light passes through droplets of water and makes the rainbow. So the white light breaks or diffracts into the 7 colors of the visible spectrum, which are in order: red, orange, yellow, green, blue, indigo, and violet. These 7 colors are the colors of the visible spectrum. Does this mean that there is invisible kinds of light? Yes, this is true. The infrared light and the ultraviolet light are examples of invisible light. The visible white light can be blocked, and when the light is blocked by an opaque object, shadows are formed. So shadows happen when the light is blocked by an opaque object from its source. Do all objects block light? Before we talk about types of objects, let's talk about this. How do we see things? How do we see colors? Objects reflect light, and according to the color they reflect, we see the different colors of the surrounding. Blue objects, for example, reflect the blue color and absorb all the other colors of the visible spectrum. Red objects reflect the red color and absorb all the other colors. What about white objects and black objects? White objects reflect all the colors of the spectrum, and you know that the mixture of all the colors makes the white color. So white objects reflects all the colors to our eyes, while black objects do not reflect anything, any light. They absorb all the colors of the visible spectrum. So the absence of reflected light gives the black color. Opaque objects block light from passing through. Translucent objects let some light pass through, and transparent objects let all the light pass through. And I told you, to identify the type of the object, we have to imagine that we're looking through these objects. Let's take, for example, the object shown in figure A. It's a cup of glass. If we're trying to see through this cup of glass, we can see clearly. This means that the light can pass through it easily, so it is a transparent object. What about the vase in the second picture? If we're trying to look through it, we cannot see what's behind the vase. So this is an opaque object. Since it blocks the view, it blocks the light from passing through. The cup shown in figure C is made of thick glass, and the image behind this cup will be unclear. This tells that some of the light can pass through this object, so it is a translucent object. And also, as you can see, look at the image of the hand behind the marble block. We can see an unclear image of the hand, so this is also a translucent object. When light hits a surface, it changes direction. Therefore, we talk about light reflection. So what is light reflection? It is the bouncing of light off a surface. And this is how mirrors, which are smooth surfaces, work. This is you looking into the mirror. The light reflected from your body on the mirror will bounce off the mirror. So you will see a clear image of yourself, a clear image a virtual image. It is the same, it has the same distance from both sides, except for one difference. It is reversed from right to left. So as you can see, if you're raising your right hand on the mirror, you will see as if you're raising your left hand. So how do mirrors work? Here is a light ray reflecting off a smooth reflecting surface, a mirror. This is the incident ray. This is the ray coming from the source of light, which in this case is you, to the mirror. We call it the incident ray. It bounces off the mirror. The angles between the incident ray and the mirror are equal on either side of the bounce. So here, angles I and R, which are the angle of incidence and the angle of reflection, are equal. A visible object must either give its own light or reflect light from another light source. Here is a source of light, which is the electric lamp, electric bulb. It is sending rays of light to a mirror, which is a smooth surface. So the mirror reflects light to our eyes, and both the angle of incidence and the angle of reflection are equal. Let me clarify the idea. This is how a regular light reflection happens, which is the reflection of light of smooth surfaces such as mirror. We will need a source of light. In this case, I have this electric lamp. Here is the incident ray. The incident ray is the ray of light coming from a light source. Here is the point of incidence, which is the point of when an incident ray meets the mirror. What you will need to do to complete this diagram is to draw a normal. The normal should be perpendicular to the mirror. Here we have the normal, and as I told you before, the angle of incidence must be equal to the angle of reflection. Let's measure the angle of reflection. It is from here till here, so it is equal to 45 degrees. The angle of incidence is equal to 45 degrees, so the angle of reflection should be of 45 degrees also. So use your rulers. 10, 20, 30, 40, 45. 45 degrees. Draw a line. And this will be the reflected ray with an angle of reflection equal to 45 degrees. This is how we draw a diagram of irregular light reflection. This is a simulation of how regular light reflection happens. We will send a beam of light to a mirror. The light reflects, and it reflects with an angle of reflection that is equal to the angle of incidence. Let's see, this is the normal. The normal must be perpendicular to the mirror. We'll use a protractor to measure the angles. Both the angle of incidence and the angle of reflection are equal. Mirrors, as I said, are smooth, shiny surfaces. They reflect light and they form a clear image. So this is a mirror, a plane or a flat mirror. Light rays coming from the object bounce off the flat mirror and create an image on the other side of the mirror. The image in a flat mirror is always upright. It is the same, it is identical to the object, but it is left to right reversed. The image formed by a flat mirror is virtual, as I told you, it's not real, and it is symmetrical. So the distance between the object and the mirror is equal to the distance between the mirror and the image of this object. Let's go again. You're looking at the image of a bottle on a mirror. So as I said, light rays coming from the bottle bounce off the flat mirror and create an image on the other side of the mirror. And the distance between the bottle and the mirror is equal to the distance between the mirror and the image of the bottle. The image of the bottle is virtual and it is symmetrical, it is always upright, but except for one difference, it is reversed from left to right. Light rays coming from the candle, let's take a look on these. They bounce off the flat mirror and create an image on the other side of the mirror. Let's see some rays on the top side of the mirror. So as you can see, the rays sent or reflected by the candle coming from the candle, they bounce off the flat mirror and they create an image of the candle on the other side of the mirror. The image, this one, is upright, it is left to right reversed, and it is virtual and symmetrical with respect to the mirror. So the distance between the real candle and the mirror is equal to the distance between the mirror and the image of the candle. Mirrors aren't the only smooth surfaces that reflect light in a regular way. Sometimes surfaces of water reflect light in the same way since they are smooth and they act like mirrors. Look at this.
Watch the sunset, yeah. Pulling eyes back in my hair and my toes curl, yeah. Yeah, you got that yum.
So the image of the pyramid is identical to the pyramid except for one difference, it is reversed. We have different types of mirrors. We talked about flat or plane mirrors that reflect light in a regular way. Look at this. The angle of incidence must be equal to the angle of reflection. What about other types of mirrors? Let's talk about concave mirrors. Light reflects on the concave mirror. This is a magnifying mirror. The image of the man is bigger than the man's face. This image is not visible behind the mirror. It is called virtual also, but it is bigger than the object. So, concave mirrors gives a magnified virtual image of an object. They make things look bigger. Look at this.
Setting this pendulum in motion. Let me try that one more time.
So the image of the ball shown on this mirror is bigger than the ball itself. So this is a concave mirror. What about the third type of mirrors? We're talking here about convex mirrors. Light reflects also on a concave mirror. The image is smaller than the object and it is virtual. So convex mirrors give a reduced virtual image of an object. This is all for today. We talked about light reflection, which is the bouncing of light off a smooth surface. When light reflects off a smooth surface, it reflects in a regular way. So the angle of incidence is equal to the angle of reflection. There are three types of mirrors. Flat or plane mirrors show a virtual image located on the other side of the mirror. The object and the image are equal in size and they are symmetrical, but except for the difference that they are reversed. Concave mirrors make things look bigger, so they give a magnified virtual image of the object. And convex mirrors are used by dentists. They are used for shaving, for makeup, to make things look bigger, as I said. Convex mirrors are used in cars mirrors, on roads, in stores for watching, and this type of mirrors gives a reduced virtual image of an object. If you still have any question about the lesson, please send me messages and I will be glad to answer them all. See you. Bye bye.